So now that I've walked through the BiFunction functional interface and talked about some of its capabilities, let's take a closer look at that case study ex11. And this will demonstrate how you can use the BiFunction to replace the value of a bunch of keys in a concurrent hash map. You can replace all the values of all the keys in a concurrent hash map in one fell swoop atomically. And as always, you can find this code in the ex11 project in my FP folder in my modern Java GitHub repository. So here we are in that project in my GitHub repository, and you can see here we've got the ex11 class, which shows how to use the Java BiFunction Lambda to replace all the values of all the keys in the concurrent hash map. And just for fun, we're also going to show how this can work with the conventional, traditional Java 7 or earlier solution that uses the old-fashioned for each loop. So the first thing we do is we have a method called makeMap. And makeMap is going to go ahead and create a concurrent hash map. And we could do various things here, but we're going to go ahead and create a concurrent hash map. And we're going to use the so-called double curly brace initializer syntax. So what this is doing is this is going ahead and initializing an instance of concurrent hash map by putting the mapping from Larry as a string to 100 as an integer, Curly as a string to the value 90 as an integer, and Mo as a string to the value 110 as an integer. So that's just creating the map on the fly. There are pros and cons to doing things this way. I like to do this for my test cases because it makes them nice and concise, but your mileage may vary, so make sure you read up on this to decide if you really want to use that approach in your programs. Here we are in the main entry point into this example. You can see that we go ahead and make ourselves a stooge map, and we print that stooge map. And then the first thing we do is we go through using a good old-fashioned for each loop from earlier versions of Java. Still works in modern Java too, of course. And we go ahead and call the entry set method, get back this entry value, and then we will take the current value of each stooge, subtract 30 from that, and then set the entry to have the new value. And lo and behold, when we print out the stooge map now, you'll see that it will have the updated map values. And you'll see that as soon as I run the program here in just a moment. Once we do that, then we regenerate the stooge map using the makeMap factor method again. Starts out with the pristine values we had before. Larry, Curly, and Mo have their initial IQs. And this time we're going to run the computation to replace all the values of all the keys using the modern Java BiFunction Lambda. So here we've got the replace all method, which is what does this or allows this. And if we take a look at replace all, as we saw before, it takes a BiFunction. And here is the BiFunction. Notice, by the way, that I've used the type deduction mechanisms. I could also expand these parameter types to have the actual type names, string, K, integer, V. But very few people will do that, so they typically write code like this. But you can use IntelliJ to go back and forth between the different forms, the concise form, the more verbose form. And then we give this as the value minus 30, or the V minus 30 part of the Lambda expression, and that's what will then be used to update all the elements. And remember, the nice thing about using replace all is this is thread safe, and not just thread safe, but highly optimized thread safe, which is one of the wonderful things about using concurrent hash map, which is why you should get used to using it whenever you can. So let's go ahead and run the program, and we'll see what the results are. And of course, we would like to get identical results for both of the ways of doing this. So it compiles it, starts running, and you can see here that we end up with the results where we start out with these values, and that's the original IQs. This is what happens after we subtract things using the Java for each loop. Everybody gets their IQ reduced by 30. Then we recompute those values with a new stooge map, run it again, except this time using replace all, and lo and behold, we get exactly what we want, which are the values that have been modified using a different approach, demonstrating the use of the BiFunction functional interface. While I'm here, I should also point a couple other things out. I could replace this stuff by using var, which is arguably more concise. I'd also make this more concise by replacing concurrent hash map with just a map here. And so that's a little bit more modern Java-ish in the programming style. As a general rule of thumb, it's usually a good idea to try to return the objects using the most generic interface that makes sense. So in this case, we make this a map.